Okay, boys and girls, we're going to start our second question now about what happens to the energy after the collision. Just remember, we're debating ideas, not people. So if somebody disagrees with you, you're just disagreeing with their idea, which is fine. These are just scientific ideas, okay? You need to raise a stick, please. You got to show me which stick you're going to raise. You're arguing for the energy stops. Because our second question is, after the collision of the two cars, does the energy stop, or does the energy go from into one car from the other? And what do you say?
I think it stops because a fast-moving car is like hitting a slow-moving car. So, example, these two batteries. This car is just moving, this car is coming in, and it just hits. I don't think it'd go. This one would just go, because it'd stop, and then this one might just go fly back a little.
Okay.
And then this car would just stay there because it hit the other car.
Okay. All right. Yes.
He said that it rolls backwards, but how does it roll backwards? He needs some energy from the other car to push into that car so it can roll backwards.
Okay, so you're saying that slow-moving car didn't just stop on its own and roll backwards. Okay. And why do you think the slow-moving car did move backwards?
Because it's a slower one and it doesn't have as much momentum to push the other car back.
Okay. All right. All right. Jacob, go ahead.
Where's your evidence?
Oh, Brody, where's your evidence for your statement? Let's take those sticks out of that. Okay.
I actually meant to raise up this one.
Okay.
Not this one.
Okay. So just an idea you had in your head. Okay. All right. Yeah, go ahead.
Wouldn't like Brody was saying, the slow-moving car traveled? Wouldn't it travel? It would travel, but both the cars wouldn't stop.
Okay. So go ahead. Go ahead.
They hit, and then the slow-moving car traveled. It didn't stop. Both of them didn't stop.
So that's what you observed, right? So you were doing the blue stick, right? Mm-hmm. Okay. So she observed they didn't stop. It just one went the other way. What do you guys say?
Another example. It'd just be going really fast, and it just might go back a little, and it won't go bam, and it just keep going on 100 other miles. Just go back a little.
Okay. Go ahead.
Let's do a real test of that.
Well, we did. We did that, and we did see that the fast-moving battery knocked the other one back, right? Okay. Go ahead.
They both went back, but the fast one just didn't go back as far because it gave some of its momentum and energy to the slow one because it was coming at it faster than the slow one was coming at it.
Okay. Well, I've seen it. What I've noticed, guys, in this current debate we're having right now, I see a lot of the in my head sticks in the air. And when we kind of get to this point where, one person thinks this and the other person thinks that, usually it's the one that has better evidence that kind of wins the debate, I suppose. So does anybody have any actual evidence from some research that you've done? Yeah.
I observed this from when we did the...
So you would have the other stick then, right? Because it's an observation. That's fine. Go ahead.
I kind of agree with Brody because it didn't go back all the way, but it went back some, and then the fast one just stopped.
Okay. So are you saying you want to switch? Oh, go ahead. That's
I
fine.
do too.
That's fine.
Can I switch?
Go ahead.
I'm switching because I thought of something before we started. I thought, right when we started, I thought, well, if they hit, they would both go far away from each other, so they wouldn't just keep giving energy to each other. They'd be far away from each other.
Now let's think about the question, though. We want to know what happens to the energy after the collision. There was energy. Both of those cars had energy. And we want to know what happened to it when they collided. Does anybody have any evidence to back up some of these things that we've been talking about? Yeah, go ahead, Lauren.
I was thinking that how could the car move if it didn't have the energy to push it back? From it, instead of it just stops.
Okay, say that again. Say it again. You guys, listen.
How would the car go backwards if the energy didn't transfer? If the car would just stop, so would the other one wouldn't move.
So she's asking you the question, how could the car move backwards if the fast-moving car didn't transfer its energy to it? She's saying if the energy just stopped, it wouldn't move at all. It would just be stuck there.
No one just pushed on the reverse to make the car go backwards.
Right, there wasn't any reverse on those batteries when they hit, was there? Okay. All right. Yeah, go ahead.
It's just like
Which stick are you holding up, by the way? Okay, go ahead.
It's it just hits it, and then it just pushes it.
Yeah,
A little.
from the momentum or the energy.
Okay.
It's from the energy it gives it, pushes it.
So does anybody have
But it's
in
not transferring. Just not transferring.
what does the word transferring mean?
Transfer means like given to.
Okay. What do you say?
If the fast one has more energy, the fast one will have more energy, so the slow one will crash into it, and then the fast one will have enough energy to keep it going.
Okay. All right. Yeah.
The slow car must have had more energy because when the crash stopped, because it obviously the fast car it didn't move at all, but the fast car it transferred the energy from its there to the slow car, so it had to go backwards. So it needed that energy to go backwards. So it sort of had the energy and some of that energy to help.
Let's do this.
I have it right here.
Let's do this. Everybody go to your research. I would say probably that paper. I mean, if you had some other research as well, that'd be okay. But let's go to your research and read.